Hello, my name is Shabnam Namaskar. My paper subject is about Smart Cloud Computation Offloading System, a dynamic approach for energy optimization. Let's begin. Now, we want to discuss what is mobile cloud computing. Although there are many definitions for mobile cloud computing, just like cloud computing, but we cannot say which of them are wrong or complete. But here we want to present a simple definition. Mobile cloud computing, at its simplest, refers to an infrastructure where both the data storage and data processing happen outside the mobile device. Mobile cloud applications move the computing power and data storage away from mobile phones and into the cloud, bringing applications and mobile cloud to not just smartphones users, but a much broader range of mobile subscribers. Now, why mobile cloud computing? First of all, extending battery lifetime of mobile devices. Second, improving data storage capacity and processing power of mobile devices. And improving reliability because it decreases the failure probability of requested computation, and we are always sure that the processed data is stored somewhere in backup and always can be restored. Now, we are going to know what is the effect of 5G mobile wireless communication on mobile. First, heterogeneous multi-radio and multi-cell connectivity in network devices. It is common belief that 5G wireless systems will not be a universal one-size-fits-all solution, but rather become a coverage set of various radio access technologies integrated under the control of operator's cellular network. Along these lines, the paradigm of heterogeneous networks has been introduced as a next-generation networking architecture, enabling aggressive capacity of coverage improvements towards future 5G networks. Second, network-assisted device-to-device communications. As you know, with the growth of network in future, increasing the number of base stations are expensive for operators. But 5G has a solution for that, and it provides device-to-device communications. Third, common Internet of Things. With existence of heterogeneous networks and device-to-device communications, 5G can be a good solution for the new challenge that is called Internet of Things. And finally, energy efficiency and green networking. 5G can be a good infrastructure for green networking. For solving the problem of intensive processing in mobile devices and according to time limitations for processing and other limitations of mobile devices, we are going to use MapReduce programming model. But first, we want to discuss about the previous solution problems. A few papers worked on operational methods with a small population and without environmental diversity, which is not always functional. Some other papers worked on investigated application program, which makes this limitation on mobile devices that all of them should have same program for process. Some other use competitive methods that nothing is mentioned about time limitations. Other have previous approaches for cloud offloading with other issues, which limited all of the processing to cloud. Now, we are going to use advantages of the proposed techniques in the suggested method. System model description. In this picture, you can see the whole environment of a mobile device. As you can see, a mobile device has an application with insufficient resources or is not able to complete the processing in a predetermined time. As you can see in the picture, some of the devices cannot proper and effective connection with the cloud in a specific moment. Accordingly, due to this poor connection to cloud, device may not be able to offload the calculation. In this situation, the suggested smart and dynamic model works with the help of the colleague cloud. Here you can see the whole scenario as a sequence diagram. The primary node sends the n-1 of other parts to a service broker, which is located on the edge of the wireless network, and we call it the colleague cloud. In this phase, those devices with the proper availability to the colleague cloud are chosen based on processing power and the size of their free sources. They are called worker devices. The colleague cloud offloads the task of the primary node as a mapper. Most probably, these devices can complete the assigned tasks. The inter-process response is ready after preparation. The inter-process responses are sent to the colleague cloud to be posted in aggregation to cloud, or the reducer runs on the inter-process responses till the colleague cloud sends back the final response to the primary node. But here, there's a small probability that worker mobile nodes may not be able to perform the assigned tasks. In this case, the colleague cloud sends the undone task to the cloud as a mapper task. Now, the cloud prepares the relative interprocess response to be aggregated with other interprocess responses in future. Thus, we have three types of offloading: all offloading, non-offloading, hybrid offloading. As long is the number of the process segments in T period, we have input currents to each of the cause are shown by each time period of T. The expected total average time should be equal to gamma. That gamma ms is for sender, gamma md is for receiver, gamma n is for network, gamma c is for cloud. To stabilize the system failed segment to process the tasks based on deadline should not exceed or be equal to a certain value of beta. According to what discussed before, we can define 5Q as the following picture. So, QUMP includes the parts which have been recently partitioned in the primary node or the ones which are going to be processed locally. QUMES stands for all the parts which fail to be processed loading. QUN stands for the network resources. QN includes the parts which are currently using the network resources, and QUMW refers to the parts which have been offloaded on the worker's node. So, the consumption of the energy per each mobile device is calculated as EM. On the other hand, the energy consumption of the idle device, or the one waiting for the response after offloading, is calculated as E idle. So, regarding what offloading mode and what activated queue in which period of time energy consumption for the calculation is derived from E total equation for n parts offloading of an application. Now, the calculation time in a period of time for n will be T total. According to what mentioned before, the goal is to optimize the equation in offloading processing during the whole modes and time periods. Now, we want to talk about our optimization method. The design of our algorithm was based on Lyapunov optimization method. This method works based on the present time data and does not require future data or the state of distribution in the system. To optimize the state of searches in the system to find proper condition, we get use from the decision function. So, the description of Lyapunov function would be as the following. Now, the will be the sum of the energy consumption of the wireless devices plus the energy spent for sending. Now we are trying to describe an upper bound for this function by using the available queues. Here shows the suggested algorithm to get an optimized solution in the most appropriate time. In this algorithm, first we will have a comparison of queues and then activation of longer ones. If one queue is longer than the other, its processing and transferring speed will be adjusted in a way to be done sooner. Consequently, by this method, we will have a fair data flow between the queues, shorter processing time, and accordingly the tasks will be assigned to convenient nodes and links. The following equation shows the capacity extent for the queues where epsilon is more than 0. As I mentioned before, there will be these relationships between our algorithm and optimized solutions. Now, we want to talk about the simulation and their results. For simulation, we are supposing that the jobs of a process and their relation is mapped to a graph like this. Now, we want to compare the results. Comparison of transmission rate and processing density on the time average energy cost in all offloading type, without offloading type, and hybrid offloading shows time limitation in our method will have a significant effect on the enhancement of the energy optimization in a specific time. Now, we compare three offloading scenarios on the energy cost. Our first aspect comparison, our second aspect comparison. Now we compare execution time. Comparison of execution time of algorithm with 20 unequal jobs. As a conclusion, dynamic and smart model based on the optimization method of Lyapunov, which enables the mobile device to get help from a middleware server if the device could not have a direct availability to a cloud. Thank you very much for your attention.